All right, hi there. I'm going to attempt to give a bit of a more comprehensive tutorial on partial fraction decomposition and basically give you the tools to solve any equation that your teacher or professor might throw at you. So at first, I'm going to start by going through the steps with one example. These steps are going to work with any example, but then I'm going to go through afterwards the different complications that your teacher or professor might throw at you and how to go about solving those. So first, let's look at what this is. So basically, partial fraction decomposition is breaking big fractions with polynomials into smaller, easier ones. So what people much smarter before us have figured out is that you can take these denominators, these factors, and break them up in this form. So you take the first factor, throw it over here, put an A over your thing, plus your next one, throw it over here, put it in the denominator, put B on the top. And these A and B, they're arbitrary, but they're just constants. So basically you take the big fraction, you split it up into its bottom parts, into this form, and we have some constants on the top. So basically this is what our answer is going to look like. We just don't know what the A and the B are yet. So how do we solve this? What we're always going to do to solve for the A and the B, which is basically all that partial fraction decomposition is, solving for the numerators that we don't know, is we're going to get rid of this denominator. How do we do that? We multiply the numerator by the denominator. So now this is going to cancel with that. That's going to cancel with that. We got rid of our denominator. Perfect. However, if we do it to the left side, we have to do it to the right side too. So I've run out of space a little bit, but we're going to be multiplying the same thing over here. So I'm going to rewrite this down here. We've gotten rid of the denominator on our left, so we just have 5x minus 13. But now we have our a over x minus 2 plus b over x minus 3 times x minus 2, x minus 3. So now what we need to do, and again, we'll always be doing this, is multiplying this stuff out with this. So we're just multiplying it all out. So I'm going to write it as we go. Our left-hand side stays the same. Now we need to, for this left term, multiply this into here and then this into here. So let's start with the x minus 2. We get a times x minus 2, and this is over x minus 2. But the cool thing here, we're going to get cancellations. So when we multiply this first term in, it's going to cut out our denominator. So we just have a, but now we need to multiply this in. So we're going to get a times x minus 3. Now let's do the same for the b. We have b over x minus 3 times, we can do this one first, x minus 3. That's going to cancel with that. So we can take that out. And now we multiply our next term in, b times x minus 2. So what you may notice here is we basically exchanged what was our denominator for being multiplied by whatever wasn't it. So a ended up being multiplied by x minus 3, and b ended up being multiplied by x minus 2. You can take that shortcut if you want, but that's how you get there. So now, again, we know that our answer looks like this, but we need to figure out what the a and the b are. So what we're doing here is we're solving for a and b. Now we have it in the form that we want, and it's going to make it easier. The problem is we have one equation with two unknowns, our a and our b. The good thing is that we can multiply, or we can plug in for x whatever we want. And so the strategy always here is going to be plug in numbers for x that cancel out a or b. So we get rid of one of them and we can solve for the other one. So here we could plug in 3 for x, and that would make this a times x, which we're going to plug in 3 minus 3. That is going to cancel a out because it's going to be a times 0, and we're going to get 0. For b, we could do the same by plugging in 2 for x. So I'm going to go with plugging in 3 for x. So I'm going to say x equals 3, and that is going to give us 5 times 3 minus 13 equals a times 3 minus 3 plus b times 3 minus 2. So we can simplify this. This is just going to turn to 0, so we can kind of ignore it. We're going to get 15 minus 13. 15 minus 13 is just 2, so I'm just going to write 2 equals nothing here, since that's just 0. B times 3 minus 2. 3 minus 2 is just 1. Anything times 1 is itself. So we have b, I'm going to write it up here, equals 2. That wasn't too bad. So now I'm going to rewrite our initial equation. We had 5x minus 13 equals a times x minus 3 plus b times x minus 2. But we just solved b. So now instead of b, we can just put 2. So now we only have one unknown. Makes it a lot easier to solve for a since we don't have to cancel b out. So you can plug in whatever you want for x. I usually do 0 or 1 since they're the easiest. So I'm going to plug in 0. So we get 5 times 0, which is just 0, minus 13 equals a times 0 minus 3 plus 2 times 0 minus 2. I'll rewrite this again. Negative 13 equals, this is going to become negative 3a plus, we're going to get a negative 4. So I'm just going to say minus 4. Now we need to solve for a. So if we add 4 to both sides, we're going to get negative 9 equals negative 3a. If we divide both sides by negative 3 to isolate the a, then we get 3 equals a. So I'm going to put this up over here. A equals 3. Excuse my sloppiness. So, again, we know that our answer looks like this. We just needed to know what a and b were. So now that we've solved for a and b, again, our answer is going to be a over x minus 2 plus b over x minus 3 But again, we solved for a and b, so we can just put in 3 over x minus 2 plus 2 over x minus 3. And that is our solution. So that's all we need to do. And again, this is useful because we're breaking up complicated fractions into more simple things. So it's going to be really useful for calculus, differential equations, whatever you want to use it for. Yeah, it's going to make it way easier. So that is basically the methodology. It's going to be different or more complicated for different situations. But again, multiplying the numerator by the denominator on the left side, cancel this stuff out. Then you're just going to get this, the numerator from the left side, equals all of this stuff. You're going to multiply it out, and you should end up with some form of a times something plus b times something, and then c times other things. You're going to plug in numbers for x that cancel out enough terms so that you can solve it for a or b. So we plugged in the 3 to cancel out a so we could solve for b. Then once you're just down to one unknown, one a or b or c or d or whatever, solve for that thing and then plug your stuff into here. Okay, so that's the methodology. These are the different situations. So, as I was alluding to earlier, you might have more terms. So before using the knowledge that we talked about, we would say a over x plus 1 plus b over x plus 2. That's what our answer would look like. But if they give you more terms, it's simple. You just keep going. X plus 3. If they gave you another one, x plus 4, then you just tack on another term, d over x plus 4. Nothing too hard there. They might give you an unfactored denominator. So, in this case, I'm going to write it on the left here. You would really just have this and then factor it. So you're going to want to factor it. This is actually the denominator I gave you before. X minus 2, x minus 3. And then your answer would look the same as what we know. A over x minus 2 plus b over x minus 3. So don't panic if they don't give you something in the form that we talked about before. You just need to factor it however you can and then break it up again. They might give you exponents, and this is where it gets a little tricky. So they might give you something that looks like this with an exponent on the outside. So if you get an exponent on the outside, all that means is that you have another one of these terms, right? So we can rewrite that like this. These two things are the same. And it's just like above. If you have more terms, then you just write out more terms. So you'll have a over x minus 2 plus b over x minus 2 plus c over x minus 3. Nothing too hard there. The only trick is you need to not confuse it if you have an exponent on the inside of one of the terms. If you have it on the inside, that's different. And it's actually going to change what our answer looks like, annoyingly. So I'm going to just write out what the form of the answer will look like, and then I'll explain it afterwards. So here we have two terms. So our first one is going to be ax plus b over x squared minus 2, the denominator here, plus cx squared plus dx plus e over x cubed minus 3. So you may have caught on to what it looks like, but basically, whatever the exponent of the denominator is, you take that down by 1, and you start writing out your terms, continuing to take it down. So in this case, we have x squared, so we get ax plus b. In this case, we have x cubed, so we get cx squared plus dx plus e. And these letters are arbitrary. They don't have to be in alphabetical order. There's no, there's nothing deep about why they're A, B, C, D, E. The point is that we're just having more unknowns here. So we have to write out more letters. And again, we're starting one down, and we continue to go down. So if you have cubed, you have x squared, x, no x. If we had some term with an x to the 4, the numerator would be, ax cubed plus bx squared plus cx plus d. So your answer form is going to look a little the same or look different, but how you approach it is going to be the same. Again, we would multiply the numerator by the denominator, so it would be x squared minus 2, x cubed minus 3. These would cancel. You'd multiply this side by that stuff. Everything looks the same strategy. The answer just looks different. You're going to have more unknowns. It's kind of annoying, but it all works the same. And then finally, they might have a polynomial in the numerator. So you could solve this out the same as before. You could multiply, the numerator by all of these terms, You could have, a over x plus 1 plus b over x plus 2 plus c 3 plus d over x plus 4. You'd multiply the whole thing by all of these terms. You could solve it out from there. That would totally work. However, if they give you a polynomial in the exponent, there's a good chance that you can make your life a whole lot easier if you factor the numerator. So this would be x plus 2, x plus 4 if you factored it out. So we have to erase that. Bring that over here. And you can get cancellations. So if we cancel all those out and remove them, you'd have the 1 here over x plus 1 and x plus 3. So now this looks a whole lot easier because your answer form is going to look like just that with way fewer terms. So now when we multiply by x plus 1, x plus 3, and we get this stuff to cancel out, and we get 1 equals multiplying. Excuse the sloppiness, but I want to go a little fast. So then if we multiply these out and all of that jazz, we just get a times x plus 3 b times x plus 1. This is going to look way easier, right? So then we could plug in -3 for x here, solve it out. That would cancel that out. We could solve for b. Then once you have b, you can solve for a. Way easier than having a whole bunch of terms. So those are all of the variations I've seen on this. Oh, and by the way, just because they have an exponent on the top, or a polynomial on the top, it does not mean it's going to cancel out. I gave you the 5x minus 13. That did not cancel with anything. So don't freak out if it doesn't cancel. Like I said, you can still solve it out. It's just, it might be easier if you can get something to cancel. Okay. Those are all the forms. That's how you deal with anything. But again, this same methodology is going to apply no matter what. Leave any questions in the comments if you have them. That's it.